Hello students, in the last lecture I started data transfer group instructions and there I discussed MVI RD data or MVI R data, whatever you write, both the representation means the same thing, where data will be of 8 bits and R is the destination register and it can be any register of 8085 microprocessor. So I discussed this instruction in my last lecture. So moving ahead with the data transfer group instructions only, the next instruction that we will come across is MVIM data 8 bits. So what does this instruction do? This instruction copies the 8-bit data into the memory location. So for example, MVIM 57H. What is memory location? I have told you memory location is specified by the content of HL register pair. So at the time of execution of this instruction, microprocessor will see what is the content of HL register pair in the 8085 microprocessor. Suppose the content of HL pair is 6050H. So what microprocessor do? After the execution of this instruction, this 57H will get stored in the memory location whose address is 6050H. There this 57H will get stored. Again I am repeating, what does this instruction do? It copies or it stores the immediate data whichever is mentioned here into the memory location which is specified by the content of HL register pair. So here I have written also what MVIM data 8-bit does. It loads an 8-bit data given within the instruction into a memory location specified by the content of HL register pair. Now as I have told you in my previous lecture also that all the data transfer group instructions just copies data from one place to another, so it does not affect the flags of 8085 microprocessor. So flags affected will be no always for data transfer group instructions. Now number of bytes involved. Now as I've told you, to calculate the number of bytes you need to see how many hexadecimal numbers are mentioned in the instruction. As you can see in the instruction MVIM 8-bit data, only 1 byte hexadecimal number is mentioned in the instruction. So the total bytes of the instruction will be 2 bytes. Why 2 bytes? 1 byte will be the opcode of this instruction and the second byte is the data, 8-bit data mentioned in the instruction. So the whole instruction is of 2 bytes. Now coming to the machine cycles. So how many machine cycles will be needed for the execution of this instruction? Let's take the example MVIM 57H. So how this instruction, when you will write this instruction, it will get stored in the memory. So this instruction is of 2 bytes. Obviously it is going to occupy 2 memory locations of the memory because each memory location is of 1 byte. Now how this it is going to get stored in the memory? First the opcode will get stored and in the successive memory location whatever data is mentioned in the instruction, that data will get stored. Now at the time of the execution of this instruction, microprocessor will use first machine cycle for fetching the opcode. Once the opcode gets fetched and comes into the microprocessor decodes that opcode and it will come to know that it has to store some data which is in the memory, which is actually stored in the memory, into some memory location. Now second machine cycle will be used for fetching the data which is stored in the memory so that it can store it into the machine cycle, into the memory location. So the second machine cycle will be used for memory read. First for opcode fetch, for fetching the opcode and decoding it. Second machine cycle will be used for memory read, for reading the data that is mentioned in the instruction. Now once it gets the data, then microprocessor will come to know Once it gets the data, then microprocessor will come to know that it has to store the data in the memory location which is specified by the content of HL register pair. Suppose the content of HL register pair is 6050H, so the third machine cycle will be used for writing the fetched data, that is 57H, into the memory location 6050H. Fine. So there will be 3 machine cycles used for this instruction. First for opcode fetch, second for memory read, that is for reading the data that is stored in the memory, and third for writing that data into the memory location which is specified by the content of HL pair. So 3 machine cycles. Now how many T states? Obviously I have told you there will be 3 machine cycles. Opcode fetch machine cycle contains 4 T states. Then it needs memory read and memory write machine cycle, all total 3 machine cycles. So opcode fetch needs 4 T states. Memory read machine cycle needs 3 T states. Memory write machine cycle needs 3 T states. So all total 4 plus 3 plus 3, 10, that is 10 T states. And what is the addressing mode of this instruction? Again, since the operand on which the microprocessor is going to work, the data on which the microprocessor is going to work, or the data which the microprocessor is going to store, that data is mentioned in the instruction. If the operand is clearly mentioned in the instruction, then that type of instruction will have immediate addressing mode. Or its addressing mode can also be said, it can fall under immediate addressing mode, or it can fall under registered indirect addressing mode. Why registered indirect? In registered indirect, what I have told you, that the address of the operand is indirectly specified by memory location. So here you can see that data, the destination where the data is going to get stored, that address is indirectly specified by this memory location. So the next instruction, so this was all about MVIM 8-bit data. Hope you understood this instruction. The next instruction that I am going to discuss is MOVRDS. MOVRDS, MOVMRS, MOVRDM. So what does this instruction do? Here I have written RS and RD. So RS represents the source register and RD represents the destination register. What this instruction does is it copies the content from source register to the destination register. For example, MOV B, C. Both are registers. So what it will do, it will copy the content of register C and it will store it in the register B. It copies the content of register C and store it in register B. So this is what the instruction does. Now flags affected, obviously it comes under data transfer group and only copying operation is done in this instruction. So no flags will get affected. Now number of bytes. Now as you can see, MOV RDS or example MOV B, C. This instruction has no hexadecimal number mentioned in this instruction. So this instruction will be of 1 byte only, and that byte is the opcode of the instruction, and no hexadecimal number is mentioned in the instruction. That's why it is of 1 byte only. So the number of bytes is 1 byte. Now how many machine cycles will be used for execution of this instruction? Now let's see. MOV RD, RS, or you can say MOV B, C. So if this instruction has to be stored in the memory location, how it will get stored? Since it is a 1 byte instruction, so only 1 byte will get stored in the memory location. It will occupy only one memory location, and that also where the opcode of this instruction will get stored. Now during the time of execution of this instruction, what will happen? Microprocessor will first fetch the opcode. So first machine cycle will be used for fetching the opcode, and after fetching, when the opcode reaches the microprocessor, it will decode and it will come to know that it has to copy the content of register C and store it in register B, or whatever registers are mentioned, it has to copy the content of source register and it will store it into the destination register. Since all the registers mentioned in the instruction are within the microprocessor, so no extra machine cycle will be required for either memory read or memory write or etc. We do not need any other extra machine cycle. So in that opcode fetch machine cycle only, microprocessor will execute the instruction, because both the registers are mentioned in the microprocessor. So in one machine cycle only the whole instruction will get executed. So the number of machine cycles is 1, and that is opcode fetch only. Number of T states, obviously it requires one machine cycle, that is opcode fetch, and the opcode fetch machine cycle has 4 T states, so it needs only 4 T states. Now addressing mode, obviously as I have told you, when in an instruction the content, the operand, if the address of the operand where the operand is stored, if both the addresses they are registers, if registers are only mentioned in the instruction, then that type of instruction will have register addressing mode. So this is all about MOV RD, RS instruction. We'll proceed further with MOV M, RS instruction in my next lecture. I'm ending this class here.